All right, great. Hope you guys can see it. Yeah, let's start first with some agenda that we're gonna cover in this meeting. So first, just like a brief overview, who we are. Then we go for the need of orchestration, our use case, why we went for Netflix Conductor, how it fits in our architecture, and then we go over a real example, which is the pneumothorax. I'll go over details on this one later in the meeting, and some lessons learned that we got along the way. And then this final demo is actually, here's just like an overview of the pneumothorax, and then here's like I'm gonna do like an end-to-end demo of the use case. So first, who we are. GE Healthcare, it's a leading global medical technology and pharmaceutical diagnostic and digital solutions innovator. We heavily invest in research and development, more than 1 billion annually. We support 300K patients globally daily. 4 million image mobile diagnosis and monitoring devices worldwide, and more than 2 billion patient scans managed by GE technology annually. So those scans involve like X-ray, CT, MR, ultrasound, and a lot of other modalities. We employ 47K employees around the world in more than 160 countries. And we have more than 11K patents granted globally. So I want to start this one with for now, from a holistic view of what you're talking about of precision health, right? So if you see the healthcare space, right? The healthcare space as a whole is moving towards precision health, right? Instead of like just look at the patient as just you do a scan and then like you get some image and then you do like you provide some diagnosis. Instead of doing this, we are going to approach to care that is integrated, efficient, and highly personalized to each patient, right? The scale and breadth of our portfolio, along with our digital capabilities, uniquely position us at the center of this ecosystem, striving for precision health, right? So our goal is to deliver increased capacity, improve productivity, and better patient outcomes for our customers. These are the key challenges to overcome to support the delivery of precision health, right? So how we can do this, right? Like if you think about like AI, for the potential of AI to be realized in healthcare, the first step has nothing to do with AI, right? In fact, the first step is like we need to break down decades of entrenched data silos that exist within a hospital setting, right? We have a lot of data scattered, like a lot of different systems, like a very legacy systems. And in order for us to make like AI work, we need first like aggregate all of this data, right? Imaging, MR, pathology lab, patient generated genomics, and etc. So this is what's going to guarantee for us to have, let's say, a holistic view of the patient. For this, once you have all the data in one place, then we can run the AI, right? And we need a platform that can connect those different AIs, like saying, hey, I have one model that I want to get an input, run some inference, get an output, connect with another model, take some decisions, notify some systems, some downstream systems. So we need to connect all of those pieces together. And then for this, that's what we have here in this slide, the Edison OpenAI Orchestrator. So this is the platform that allow us to build all those puzzles together. So what are those AI applications that you're talking about here, right? Like if you think from the from the modality perspective, like every everything like that you have here in parentheses are for modalities, right? Like here I have, let's say, an MR modality, like a digital X-ray, an X-ray, CT, and etc. So those are different applications. They can run as AI, right? Like I can develop models that we can we can do inference with those models. So for example, I can have like a model that identify multiple sclerosis. I can have a model that like identify abnormalities and strokes on the head. another one that detects chest abnormalities, and so on and so forth. So now let's try to just see some few examples here. It's one of those models that we have. So here, for example, right, on the left side, right, like I have a conventional MR image, right? And then if you see there is some noise in this image, right? This is if you think from the MR machine, this is a natural process that happens on the when you output the image. So the question is, can we build an AI that like can enhance this image, that can like do some reconstruction of this image? And the answer is yes, we can. So if you look on the right side, right, we have like this image here with much better quality than this one here. So like the radiologist, for example, could spot any abnormality here between left and right. Next example, like you go in the patient room, you are scanned by a technician, but let's say, for example, the technician is not positioning you well, right? I mean, this is a human process, right? So like this can lead to failures, right? So, and the fact that the technology is not like positioning you well can lead to like a image with not so good quality, right? So therefore, one of the applications that can be orchestrated by our Edison OpenAI orchestrator, which is based on Conductor, is the AI Autorex, right? Here's an example for the brain, and then like we can give those auto lines that you see here, and then this can be like used as reference by the technician, so he can just follow the AI to position of the patient. Another one, like you have two views of the spine, right? And you want to do auto labeling of those of the spine, right? Having said that, like why we need orchestration, right? If you see like when you implement like all of those AI tools is a very complex and difficult process, right? So we are talking about like think about the data science, right? Like he's like training and validate models on a daily basis, but then once you try to ship this to production, like there are other pieces of this puzzle. So like how I how I first fetch the images, right? Once I fetch the image, how I send this to the first model, how I get output of the first model and then connect to a second one, and so on and so forth. So if you see all of these problems can be modeled as a graph, but from the perspective of the data science, like there is a lot of other steps that happen before even like building the model. So also, integrate this with multiple vendors is very risky and could lead to errors, right? We need like a unique platform that can like connect all of those pieces together. Like I said in the beginning, right? Like if you think from the data perspective, so there are, if you think from the hospital perspective, there is different like systems there, and like it's a very manual disjointed process, right? So like I have assistant A for doing something, assistant B to do another thing. So like how I put like all of those things together. And last but not least, like radiologists, like it's very good to them like that they can experiment with AI algorithms in their clinical workflows, right? Like I want to put a model in production, and I want to say, okay, this model is good if I set a threshold of, let's say, 85%. So like if the inference is telling me that like 85% of interval of confidence, I want to trust this model. Otherwise, I don't want to trust. And this like can change per deployment, right? So if you go over the AI developer journey, right? Like let's say I'm a developer, right? I'm trying to build my model. So usually what I do, right? Like I can get thousands of samples, right? I train my AI model, I do some validation, and I repeat this process over and over, right? Eventually, my model is going to have, let's say, some good accuracy, and then I'm going to say, okay, that's fine for production. The answer is actually no. And the reason is, as I said before, if you think from the perspective of like you as developer building an AI model, you are just in this box here, right? There is this inference box in the middle that you build. Like your AI model is, you know, is running here. So how can you connect those pieces that happens before and after the inference, right? So like for example, if you see this slide, this is a very high level overview what means a clinical AI workflow. So like we start the process like checking if like if the study that I'm receiving is a match. So like am I receiving a X-ray study, and do I have my model prepared for X-ray studies? If not, does not make any kind of sense to run this AI model. So it's a business logic validation, right? If yes, like I fetch the image, but like do I have the image? Was this process like okay? If no, again, nothing to do, just notify the user. But if yes, then you do the inference, right? Here's like you run your model. If the inference is okay, you store the results. If not, you notify the user. And finally, you always notify the user in the end, right? So if you see, this is a workflow. This is a graph that can be modeled as a conductor workflow. So in a nutshell, what are the challenges that this AI developer has, right? Like you know, it's very hard to integrate those deep learning models in a medical space, right? So how I fetch those images in the hospital, how I do decisions in a simple and flexible way. So as I said before, if I have an X-ray model, I just want to run this model if I receive an image of X-ray. If I receive an image of, for example, of CT, does not make any kind of sense to run this model, right? So how I store those images back? So once I do the inference, this inference can produce like mainly two types of data. Can be like, say, you know, some classification that says just, you know, yes or no, some clinical condition, or it can be, you know, some can be some um, segmentation, right? Like I'm producing images back. Um, so therefore, like I need like a system that can do all of this. So how I rate limit on those requests. So if my inference is receiving like a lot of requests, I want to limit this, right? So then like how can you use the like a conductor to counter this? And last, right, like, do we need to keep repeating all of this like for every single end-to-end flow? Uh, in the end, we need a system that can manage the call to those different microservices, guide decisions based on user-driven clinical healthcare workflows, be developer friendly. That's very important. And especially for our use case, it's very important that like we can deploy this not only on-prem but also on cloud. That we need some tool that can be easy to maintain, scale, and has low footprint for on-device use case. So this on-device use case, you can think about like you are in a hospital. There is like a lot of, let's say, restrictions to this data to go out, do it to patient data, right? And also because you want to run this fast, so like you need to run this on the device. So like we need a tool that can do this. Then we went for Conductor, right? Why Conductor, right? Conductor is very easy to deploy. You know, it's just a Java application, so the bare minimum that you have in Conductor without any sort of, let's say, JVM optimizations and, you know, nothing like that, is like around 400 MB or so. And then it even like when you do like huge amount of load on Conductor, you don't see like memory growing. So like that's a a low footprint and very easy to deploy. It's very developer friendly. So bullet 3 and 4 here is all about the JSON, right? So like you know uh I just give you a JSON. The JSON describes really well what I want to do. Like you read that JSON as like a plain English, as a as a graph, and that's it. And the fact that it's a JSON, right, like allows us to build custom workflow designer on top of JSON definition. So like uh, I can give you to developers saying, hey, here's an API, you can just send the JSON, and I'm gonna run this workflow for you. But also on top of that, I can build like custom UIs that like the developer can drag and drop like conductor tasks, and then like you can just run this. You can create your own workflows. And last but not least, the workers is very easy to write and scale. So like in fact, if you just understand like how works the pool API of Conductor, you can write and scale workers in any language you want. Okay, so how Conductor fits in our architecture, right? So like uh, let's separate this picture here in two parts, right? Like on the top here in blue, right? You have the modality, which is like think about scanners, right? Like CT, MR, X-ray, and anywhere, anything in between. So and then like the viewer is what the radiologist is seeing, right? Uh, and then you have the PACS and the VNA. So those two guys here, they are our archivers. So like here's where we actually store the images. And you have, let's say, support systems like the radiology information system and the electronic medical records, right? From those components here, let's try to focus on, the PACS and the VNA, right? So those are the guys that like have the image, right? And then once you have the image in those two guys, the next question is, okay, I have an image. I want to run a clinical workflow. How I run this, right? So this guy here, the PACS, right, and the VNA, they can talk one thing called a DIPO. So this is a protocol in healthcare that allows you to exchange medical data between devices, right? So the PACS once receives the image, it can, create a payload and then send to Conductor saying, okay, I want to run, I want you to run, this particular workflow. Or the PACS can say, instead of saying, I want you to run a particular workflow, I want you to run all the workflows that you want, that you have, right? So this request goes to Conductor. We have custom works to do some processing, and also have some adapters and connectors that like can, this format here is a medical image. We need like somehow to convert this to a JSON. That's like those adapter connectors doing here. And then like a Conductor orchestrator like all of this this scenario here. So it can call the inference. It can call the different microservices that I need to have this clinical workflow running. And if you see, there are three types mainly of algorithms that you can think. One is like the algorithm is running in the same infrastructure as the all of this is a Kubernetes cluster. So like this is running the same cluster. The other one is like the algorithm is running on cloud, and then here there is a lot of, let's say, security aspects. So then we just have, let's say, a cloud connector that receive everything, and then this cloud connector can ask the third party that is running on the cloud to do the inference. And also can be in a in just, let's say, in a bare metal VM that can again be called through some tasks in the workflow. So just to highlight here a practical AI workflow. This is pneumothorax. So pneumothorax is a collapsed lung, right? So a pneumothorax occurs when air leaks in the space between your lung and the chest wall. This air pushes on the outside of your lungs and makes it collapse, right? So it's usually like you see, the two lungs, and then like when you have a collapsed lung, you feel like you see like this, that lung kind of, let's say, compressed, right? So if you see here in this image, right, like I have some compression happening here and also happening here. For like someone that is not a doctor, it's hard to see this, but like a doctor would easily spot this, right? But then the question is, okay, can I have a model that can do this for the doctor, so the doctor can, have those save time from the doctor perspective? Yes, so that's the pneumothorax model. So here, like it was so this model is just like it highlights where you have the pneumothorax and also some confidence interval. So if you look from the previous image, right, like we just have, let's say, in the left, like the lung, and the right side, like the model highlighting the collapsed lung. But the question is now, okay, how I make this thing work, right? Like what are the steps that I need to make this working end to end, right? So here's like the workflow for the pneumothorax, right? We call this PTX. So it starts with like some basic decisions. So like saying, okay, uh, is this patient, let's say, more than 18 years old? Is this image like a chest X-ray? And all of those decisions goes here, right? And then if you see, like, you can model this as decision boxes in Conductor. After, if you don't pass any of, if one of those decisions fail, you immediately end the workflow. But if it pass all of them, then you have a candidate to run that AI. So you send an in-progress notification to the user saying, okay, I'm going to run the AI for you. And then using a do while, which is, this is an HP test, the in-progress notification, and the do while is a do while of Conductor. You run over the series of that study. So like in all of those medical images, you have a study. The study is composed of a series of series, and then each series is composed by a series of images, right? So you run here, you do the loop, you do another decision, and then if it pass, you loop over the images, right, in that series. If for each image in that series, you do a C move. So again, the C move, all those black green ones here in the dark green in the slide are HTTP tasks. So the C move fetch the image from the archiver. So if you remember from the previous slide, we have the packs. So we fetch this from the archiver, and then we run the first model, which is the chest frontal. So here in this model, we are just looking and say, hey, is this image like the frontal side of the chest? If it yes, then I continue my flow. If not, I cannot run the AI because it does not make any kind of sense. But then if it is yes, then we fork. Then there is like two other models. One that tries to identify the pneumothorax. That's, let's say, the core of this flow. And one that like just give, let's say, some highlights of the position for the user. So then we run those two models. We take some decisions as well. And then finally, we store the image back in the archive. Once all of this is done, we join here as a result of this fork. And then we send back the notification for the user saying, okay, your AI is done. So all of this, if you see, can be modeled as a Conductor workflow. So some lessons learned that we went, along the way. We started like in Conductor using Reds and Dynamite for persistence. The thing is, we saw actually, especially on Dynamite, like a lack of documentation. So then we switch over to Postgres. This gives us two, let's say, advantages. So first, documentation is much better. Second, we can leverage the existing infra that you have on the cluster, and it's much more easier to operate. Uh, we also build a custom UI, to create the workflow. So if you look just from the Conductor perspective, Conductor allows you, to just see the workflow for execution. But like at the time that we start like this project, we asked us, okay, JSON is great, but like the users in the end, they need the workflow definitions. You need to drag and drop those boxes. So like, how can I build a custom UI on top of the Conductor? Another thing we learned on this is like, and we learned this the hard way, is distributed lock is a must. So like, if you run, Conductor, if you just a simple, use case, like, we don't have, let's say, much load, that's fine. But then, especially when you try to like put this in huge pressure, like a huge loads, we see like some weird behavior, especially in terms of consistency, like tasks in our workflow that depends on a task before were failing because like they were executing and the previous task was not giving the output. Then like we enable distributed lock using Redis, and then once we start like doing this, we saw like a lot of issues like going away. And just to finish here, I want to give you like a practical demo here. If you remember from that high level overview, right, like that workflow, we used to have, let's say, the inference and the store tasks there. Those are, let's say, orchestrated by Conductor. What I want to do here is I'm gonna have, let's say, a workstation. I'm simulating a workstation here, a medical workstation. For this, I'm using an open source project called Horus that like can, show me, it's like you are in a hospital and then you see all the images, you can, see the patients and things like that. Then using Horus, I'm gonna send those images to the server, right? The server is gonna receive those images. It's gonna create a payload for to start a workflow in Conductor, and then the workflow in Conductor is gonna effectively do the inference and then store the results back in the Horus. Okay. So now let me share the Horus. Actually, I'm gonna share the entire desktop. Guess this one. Okay. So here, right, I have Conductor running, right? This is my workflow. Let's go in this guy here. Okay. So what my workflow is doing, like first, check description of the study, right? So like if you go in the JSON definition, this is a mock workflow. I'm not running the actual PTX model, but it's a representative. So like I just check like, hey, is this a chest in the study description? If the answer yes, then like I move forward. If not, I just finish the workflow. Then move forward means like call a sub workflow. Then this sub workflow, which is this guy here, this guy. What this guy's gonna do is like it's gonna call the inference, right? Check the result of the inference. If it's completed, then it's gonna store the results and then send a notification to the user saying, okay, yeah, I mean, then it's completed. If it's failed, it's not gonna need to store result, but regardless, we need to notify the user of, let's say, of failures, right? So then here's Horus, right? I have a chest X-ray here, right? As I said, this is not, let's say, the real model, but I want you guys to pay attention to things. So when I hit send here, I'm gonna send those images to the server. You're gonna see here in the activate like those images being sent, and then once the conductor runs all the tests in the workflow, you're gonna see the last one is the store back. So if you refer back the diagram right here, this is the store task. Okay, that's gonna push the image back here, and then once it pushes the image back, you're gonna see a sign here, yellow sign, saying that like there is new activity coming. So that's just conductor sending back those images. So that's what I'm gonna do now. So here is my destination, my server. I'm sending this to the destination. If you see here, sending. Now Conductor is running the workflow. I can show the workflow later. But then now came back the results as per Conductor. And then if you see here, it's a added within the last 6 seconds, right? This mock model is just copying the input to the output. It's not doing, let's say, inference per se. But like if it was the real model, you would see like a second image here coming with this thing highlighted, which was one of the slides that I showed before. And then if you see here in the activate, you have the parent workflow that ran. It checked the study description. The study has that that description chest. It ran the sub workflow, which is this guy. Then the sub workflow called the inference. It checked the inference status. It was completed. It stored the results back in the Horus. And then the last task was just to notify the user. In this case, I'm just simulating notification by just writing a lambda. Yeah, I think that's all I had. I'm more than happy to connect with you guys. So leaving here my Twitter, my LinkedIn, feel free to direct message me, and I'd be more than happy to connect. Thank you.
All right. Thank you very much, Flavio, for that amazing presentation. Exciting to learn about how Conductor is used in medical, to power medical imaging and improve that experience.
Yeah, sure.
We can take questions now. So feel free to drop your questions in the chat or in the Q&A section. While we're waiting for questions, I have one question of my own. can you talk a little bit about the scale of at which you're using Conductor? Like how many workflows do you run? How many different types of workflows and different types of tasks that you have in your system?
Yeah, sure. So this depends like definitely from the from the type of the the clinical workflow. So we run workflows for like MR, CT, X-ray. So from the scale, let's say from the smallest one to the largest one, like definitely CT is the the easiest one. Sorry, X-ray is the easiest one. But then you go, let's say for CT and Mars, you're talking about, let's say, thousands of images that goes in a workflow. And then we run the inference. So like we have more than 1 million images running, let's say, annually, in a hospital, and that's the kind of scale. So as part of the test, right? Like you can think about inference in mainly running two different type of tasks. You can have, let's say, HTTP async tasks. So like the workflow starts HTTP async, and then like the inference model is responsible to resume this task in the workflow when it's done. Or we have some use case that's a very particular use case that we have, like think about, let's say, program line programs, right? Like instead of like you put, let's say, an HTTP interface between the workflow and the inference itself. You just want to run, let's say, a simple Python program, a simple Go program or whatever to do the inference, right? For this, we built like a custom worker that can manage Kubernetes jobs. So like all of this is running Kubernetes jobs. So you as a developer can define a task of type Kubernetes, right? And then we manage the entire life cycle of this Kubernetes job. Like since the moment that like you put a definition, we start this definition in the start this job in the cluster, monitor the job completion, and then automatically handle the resume of the task for you in the workflow. Yeah.
Awesome. Thank you. So we have a question here. This from Manasvi. How did you test your workflow in isolation when the clients were not ready or under development?
Yeah, sure. So so if you see the mock model that was presented is a use case for this, or like so if you think from the perspective of the inference, like the inference is actually doing two main things, right? Is reading a file in the file system, right? Getting the data, and then like just doing some API call to actually do the inference, right? So I can simulate the load just by put the amount of image that I want, right? And then I can say, okay, I can treat the inference as a black box, and then like I can move this input image to the to some output folder, and that's going to mimic the inference for me.
Right. I have another question. Is there, like you mentioned, you have a Kubernetes task that you have built. Are there any other customizations or any other features that you've built on top of Conductor that you can talk a little more about?
Yeah, so if you see, like I like to talk about this as let's say how you make the life of the developer easier, right? Like first you have an HTTP test, then for this, like the user needs to create a web service, like handle APIs and stuff like that. Then you make the life of the user a little bit better by providing like a Kubernetes job. Say, okay, you don't need to like run any sort of HTTP server. Just give me the definition of the job, and I'm going to run like everything for you, right? And then on top of this, we build like another type of test which you call, let's say, serverless. So the idea is that like you as a developer, instead of like managing HTTP service or managing Kubernetes job, you just manage code. So you give me a piece of code, I pass this to a serverless function which has input and output, and then you can do whatever you want in this function, right? So we manage this as a custom, as a simple task in a custom worker. And then what this guy is doing is effectively, just starting a serverless, a pod in the cluster, which is managed by a serverless framework on Kubernetes.
That's very exciting.
Yeah.
Thank you. Any more questions? Okay, I don't see any more questions. So thank you once again, Flavio, for that presentation and for taking our questions.
Sure, no problem. Thank you, everyone.